I'll shut up. Here is the chapter 1. Now, let me explain some things to you before we start chapter 1. And those things are, number 1, chapter 1 and 2 is 20% of the unit test. Write that down. Chapter 1 and chapter 2 is 20% of the unit test. So most of your test is going to come from chapter 3. 80%, 70 to 80% of your test is going to come from chapter 3. We're going to spend probably 2 to 3 days. If I can get faster, I will, on chapter 1 and 2. I'm going to go through, I'm going to hit the highlights of chapter 1 and chapter 2. Chapter 1 and chapter 2 is definitions. Okay, so chapter 1 and chapter 2 should not be difficult for y'all, unless you don't know how to read. And mostly all of you, especially you West Side graduates, y'all know how to read, all right? Right? Well, a little iffy, right, West Side? All right, so let's get started. And when we get to chapter 3, I'll be going section by section, and I will be doing a little bit slower presentation because that's math, and that's what you're here to learn, math. So I'm not doing away with the definitions, but I'm just not spending a lot of time on them because you can read. So anyway, I will explain them. The more complicated ones I will explain. But what is your first? There is your first definition right there. Is it a standardized test question? Oh, yes. Is it a Hubert test question? Oh, yes. Why is it so important? 1, because it starts with a capital letter. Capital letter statistics. Hold on a minute. Capital letter statistics. I don't want to, infect anybody that's 20 feet behind. Capital S statistics basically is, and I'm going to give you the layman's definition so you don't have to write all that. Collection, calculation, interpretation of data. That's what, 9 words? Somewhere around there. Collecting, calculating, interpretation of data. And you can put out there in parentheses, big umbrella, because this is the big umbrella. This is the whole thing that we're studying this semester. Statistics with a capital S. Now, why is that important? Because on a standardized test, they will ask you that question, like an ACT test, a employment test. I think some of you nursing students have to take a test to get into what's it called? Practicums, practical, where you whatever. You have to take the TEAS test. That question will be on there. All right. So I'm not going to fool around. That's it. That's what we do in chapter 1 and chapter 2. I go through the definition. I tell you if it's going to be on a test, and then I explain to you if it's a little bit complicated. And some of y'all, there's 3 people in the room. There's a few of y'all that wrote the book on mathematics. Y'all actually wrote the book. Y'all think y'all did. Then there's people that have had statistics before, and then there's people that's never had it before. I'm teaching to the people that's never had it before. Okay, that's who I teach to. All right, so next. You see I skip stuff. If I skip stuff, then that means you don't need to worry about it. You can read it. That's why I'm telling you to read it. Population, the big group. If you're doing research, the population is the big group. The sample is the little group. If I am studying Tri-County Tech students, or I'm researching Tri-County Tech students, all Tri-County Tech students would be the population. Anderson campus would be a sample. If I do calculations with the population, they will be Greek letters. You know, like a formula or an equation with letters in it, they'll be Greek. Can somebody tell me what Greek letters represent? Parameters. Population, parameter, Greek letters. So if somebody's presenting to you and they present and they go x minus mu over sigma, boom, they're talking about the population. That's all you're supposed to know. Okay? So if you see Greek letters, you're automatically supposed to say to yourself, okay, they're talking about the population. But if you have a formula with the sample, then you're talking about alphabetic variables, which is A, B, C, D, E, F, G, and that is lowercase statistics. Okay? So let me go over it again. A parameter is a variable used in a population equation, and it is usually a Greek letter. A parameter is a variable used. A variable used in a population formula, usually using Greek letters. Now you can write right below that the same thing with statistics. You can say a sample equation using alphabetic letters is called lowercase statistics. So population, parameter. Sample, lowercase statistic. And basically that's, you know, if you're sitting in a meeting one day and they throw up a x minus x bar over s, you know that is what? Sample, because that's alphabetic letters. See what I'm saying? And then if they throw up x minus mu over sigma, you know that's population. That's why you need to know the difference. So if somebody presents a formula to you, then you know whether it's a sample formula or a population formula. Make sense? And you'll see that later in chapter 3. We're going to see that. So that's a good question, though. People use that question on standardized tests. Next question, or next set. Descriptive statistic. Descriptive statistic, and put out in parentheses your test grades. Somebody tell me what I mean by test grades, your test grades. What do you do to your test grades? At the end of the semester, what do you do to your test grades? Or homework grades or whatever. What do? You average them up and do what? You add them up and divide by what? And that is descriptive statistics. Descriptive statistics do not predict. Descriptive statistics just tells you what you want to know, like the average. Boom, there it is. The standard deviation. Boom, there it is. Now you can write all that down, but it basically means it does not predict. And put test grades equals average. Now, if you don't like me bypassing a lot of junk, then you read and write down the definitions you want to write down, okay? Part of my teaching, whatever you want to call it, is I cut down to what it really means. Then you can build on that by going back and reading it and then put it in fancy words. Yes, sir.
So are your tests going to have the definition as in fancy words? Or
they're going to have the fancy words. That's why you got to put the two together. Okay? Lord, if I put my words on a test, some department head or division chair would have a fit. Okay? Inferential statistics. If descriptive statistics do not predict, what do you think inferential statistics do? That's it. Think of it like this. And you also use other people's material. You also use other people's data, like DOT. DUI, I guess you'd say DUI deaths in the last 10 years. And then you use that to predict the DUI deaths for this year. That's called inferential. We should ban cars because cars are the ones that do the killing, right? Shut up. Cars kill. Some of y'all get that, some of y'all. Anyway, inferential predicts. There's parameter. Parameter is a variable used for the population. You'll see, it'll make sense later on when you see the formulas. It'll make sense. Next. Oh, now we're getting into some good test questions now. Qualitative or quantitative? Qualitative. All you got to put blondes, brunettes, redheads. If you don't want to put blondes, brunettes, redheads, put green eyes, blue eyes, brown eyes. Somebody give me the average of blue eyes. Can't do that because the characteristics, and that's the key word here, in a qualitative set of data, you don't have mathematical meaning, you have what? Characteristics. What's the best band of all time? That is a characteristic. What is your favorite color? That is a characteristic. So, you know, when you're talking about qualitative data, it's nice to get it, but you can't do anything with it. Somebody give me the average of hair color. You can't do it. So always remember when the question asked on the test, and there will be a couple on the test about qualitative versus quantitative, just remember, give me the average of blank. If you're talking about hair color, give me the average of hair color. You can't do that. Give me the average of skin color. You can't do that. Give me the average of, you know, now you can take the average of the head count, but that's not what we're talking about. We're talking about the data, okay? And that's characteristics. Characteristics is qualitative. So therefore, quantitative is what? Mathematical. The average age of the people in this classroom, that would be quantitative. Now make sure you understand the difference between those two, because that makes a lot of test questions right there for ACT, for T's, for Bosch, for employment at Michelin. You probably see a question like that. What's the difference between qualitative data and quantitative data? How about food? How about restaurants? Good restaurants. Well, that's qualitative data. Now, the actual data, you got 5 good restaurants in Anderson. You got 10 good restaurants in Anderson. The count, now that would be quantitative, but the actual question is qualitative. There's some examples. Gender, temperature. There's a good example right there. So I'm going to leave that right there. I'm going to leave it right there. So you have 4 good examples of qualitative and quantitative. Give me the average of male. Give me the average of female. Can't do it. It's qualitative. Temperature. You can do an average temperature, can't you? You've seen the weatherman on TV, don't they say, we're going to have an average temperature this week of 63 degrees, I wish. They don't, that's quantitative. And so on. I will tell you this. There are 3 things that tests will use to try to trick you. And those 3 things are this: zip code, social security number, and area code. What are all 3 of those? Qualitative. Thank you. Because the numbers have no what? Meaning. Give me the average of your zip codes. Does that, you can add the zip codes up, but does that zip code mean anything? No, it means nothing. So you always got to ask yourself, the average of blank. The average of social security numbers. I take all your social security numbers and I add them up and divide by 30 or whatever's in here. Tell me what that zip code means. Absolutely nothing. This stuff is not hard. This stuff is real simple. Okay, so just don't make it hard. Next. And believe you me, some people make it hard. And here's 2 more good questions. And I know for a fact these are on the test along with qualitative and quantitative because I saw it. And I remember putting them on there. I'm gonna let you just write the word. Don't write those paragraphs because they're gonna confuse you. Under discrete, I want you to write the following words: predictable, locatable, countable, and rational. Some of you may remember that rational from your algebra days. And the continuous is all the opposite. So what's the opposite of predictable? Unpredictable. Well, I tell you, y'all are gifted and talented. Y'all are on the ball. What else? Unlocatable. What else? Measured instead of countable. Measured. And irrational. So let's talk about it. What is countable? Somebody give me an example of something that's countable.
You can count the number of dogs.
What?
Number of dogs.
Say it one more time.
The number of dogs.
Number of dogs. Good. I like to use eggs. Number of dogs, eggs. I like to use eggs because eggs is everything, simple to think about. Eggs. If you have a farm and you go out, remember Napoleon Dynamite working for the chicken farmer? Okay, forget it. He's not a cartoon or a Marvel comic, so y'all don't know who he is. But anyway, good movie. I love that movie. Oh my God, I laugh at that movie so much because everybody goes to high school and everybody has a Napoleon Dynamite in their school, okay? And Napoleon Dynamite, he goes to work at the chicken farm and he makes $1.85 an hour or something like that. Anyway, eggs are countable. All right, let me give you another example. Somebody take your calculator and divide 1 divided by 3. Not your phone, but your calculator. Thank you. Okay? Not your phone, but your calculator. Take 1 and divide by 3. What do you get? So what's the next digit? 3. You can tell me that the next digit in 0.333333 is what? 3. It's predictable. It's pattern. Also put pattern in there. What is the pattern of 1 divided by 3? It's a 3 repeating. There is a pattern. You can tell me what that last digit is. 3. Everybody with me? So what's irrational? Well, if I tell you to go outside and there's a fire hydrant down there somewhere, and I tell you, is everybody listening? And I tell you, I want you to measure that fire hydrant. I bring a big old box of measuring tapes, whether it's a cloth measuring tape or a metallic, tape measure, or a digital tape measure, or a carpenter's, the old wooden ones that fold up. Bring you a box, and each one of you grab a measuring device, and you go down there and measure the fire hydrant. How tall is the fire hydrant? How many? Will everybody give me the same height? Oh, hell to the no. Because half of y'all can't even read a tape measure because you're high school graduates. Okay? So half of y'all will say, oh, it's 3 foot. And it'll be like 3.5 feet. And you'll just say it's 3 foot. The other half that can read a tape measure, you'll give me 15 different measurements. Some of you would dig down to where it's the metal meeting the metal and say, okay, here's where we're going to measure from. Some of you are lazy, will just measure from the dirt up. What am I trying to tell you? When you measure something, are you all going to give me the same measurement? No. So put down there height of a fire hydrant. You'll get different measurements. Take your calculator, somebody take a calculator, and take the square root of 2. I don't know if I can do it on this one, but I'll try it. Because this is not my home computer. My home computer has everything on it. So let me see if I can do it on here. Pull up handy dandy calculator. I'm not even going to see if they got a TI on here. I'm just going to type it in. There it is. And it must be right here. Hold on a second. We're making some progress here. And 2 raised to the 0.5 power. Somebody tell me what that next digit is besides 7. Give you a $100 bill. Everybody gonna jump at it? Oh well, just get $100 to get back to that. Okay? What's that next digit? You have no idea. Why? Because it's irrational. It's not locatable. You have no pattern. That's all there is to it. Measurement versus counting. Discrete, you count. Continuous, you measure. What's the height of that tree out there? You get 15 different heights. So you need to put for continuous meters, liters, grams. That's just an easy way of saying what. What is meters? Distance. What is liters? Of volume. Grams. Measure of weight. So if I asked you a test question about distance, height, or weight, volume or weight, what will you say it is? It's continuous. And I will tell you right now that there are some teachers that will lobotomize you over those 2 words. And all they are is counting and measuring. Capiche? Yeah, Hubert, we understand. Thank you for, letting me know. Appreciate it. Y'all suck. Y'all are like the girl you take out to a nice restaurant. I'll just take water and a carrot stick. Y'all know who I'm talking about. Huh? Oh, we're gonna be funny. Okay, howdy doody. We're gonna be funny. All right. You don't even know who howdy doody is. You have to look it up. All right, next. Let's see what else. Okay, here's the first example of what I do not usually test you on. I don't usually test you on the different, what do you call it? Hold on a minute, I'm trying to chew gum and walk at the same time. The different levels of measurement, I want you to write them down, and I want you to be aware of them, but I'm not going to test you on them, okay? Nominal covers everything. Okay, what about temperature? It's nominal. What about temperature? What about weight? That's nominal. Nominal covers just about everything you can research. It's an umbrella. Ordinal. All you got to put beside ordinal is order. How many people come in different at a race? That's called a ranking. You can put ranking beside ordinal. The reason I don't test on these is because some of the questions are so confusing that I just don't fool with it as far as a test question. Interval. Okay. And there should be absent. There it is. A value of 0 does not mean the absence of the quantity. And arithmetic operations such as addition and subtraction can be performed on values of the variable. And ratio, poor ratio. This one, a value of 0 means absence. A value of 0 means absence. And on the next page, you're going to get some good examples. So I want you to be aware of it. Why do I want you to be aware of it? Because you probably see it on a standardized test, but you won't see it on my test. So far, everything I've covered will be on both, but this is the only one that I don't usually test on that one. And here's some examples. Gender, like I said, you can put anything under nominal, and gender is one that is nominal. Temperature is interval. Can I add 70 degrees and 80 degrees and take the average of 70 degrees and 80 degrees? Yeah. That's interval. Number of days a student, what does it say? Number of days the past week that a college student studied. That's ratio, or over ratio, because I could do 2.5 days. And the last one, letter grade, erase, anything like that is ordinal. Question. And as you can see, we're moving quite along. It's just definitions. That's 1.1. So you probably got how many questions out of there? 5 or 6? You got discrete, you got continuous, parameter, statistic, lowercase, uppercase statistic, qualitative, and quantitative. Somebody tell me, is that 7? I think that's about 7 questions right there that could be on your test. That's how I do things. That's how I go through these definitions. So let's move on. 1.2. Let me go back and make sure I didn't miss something on that first page. because they change these books like every 2 years, so I don't think so. Observational versus experiment. Now this is pretty simple. Any of y'all ever seen videos of people with sleep apnea and they got all these wires hooked up to them and they're sleeping and you got, they're in this night vision, and in this lab, and I don't know if you've ever seen them before. That's observation. Observation is when you just what? You just observe, you just watch. Some of you Star Trekkies, some of you people that watch Star Trek, I'm a Star Trekkie. I'm not a Star Wars person. I've watched all the movies. I don't care nothing about Star Wars. My son does. He likes Star Wars, but I never did like it. Anyway, I'm a Trekkie. I watch all the Star Trek movies and all the Star Trek, except for Sleep, Space, Nine. I care nothing about that. But anyway, in one of the episodes, and several of the episodes, the Star Trek people, they will camouflage themselves on a planet with cloaking materials or whatever, and they'll watch other cultures and other civilizations, other planets. That's observational. That's an observational study. Observation. DOT. You can get a job in DOT just counting cars. That's observational. When it turns into experiment is when you interject something into the observation. Let's say that every fifth car that I count, I shoot the back tail lights out, or I shoot the back tire out. That's an experiment. Okay, it's illegal, but it's an experiment. All right? Sorry I mentioned the gun. Guns kill people, cars kill people. So, just want to mention that. If you have a mouse and you put him in a maze, that's observational. If you throw a piece of cheese in the maze, what have you done? You turned it into an experiment. Now, there are people that will argue that you threw a maze in the mice or mouse's world, and that's an experiment. You could argue that, yes. But I'm trying to show you the difference between the two. So, okay, I'm going to say put a mouse in a box and then put a mouse in a maze. Okay, that is an observation and an experiment. If you are running the mouse through the maze all the time and then you put a piece of cheese in the maze, that is the difference between observation and experiment. When you interject something into an observation, it is considered to be an experiment. Watching the sleep apnea people, and whenever one of them move, you hit them with a cattle prod of 15,000 volts. That's the difference between an observation and a experiment. Some of y'all don't even know what a cattle prod is, but that's okay. Question, right, complaint. I gotta lay off them Marlboro Reds. Oh, all right, that's all right, I got COVID. Smoked for 1,000 years, 2 packs a day, you got COVID. I'm trying to find something else that's pertinent. Census. Now, I'm not going to tell y'all what a census is. If you don't know what a census is and you're in college, okay, that's sad. All right, but it's basically information taken every what? Every how many years? Here, every 10 years. Census. Is that a test question? No. Could it be a standardized test question? Yes. I don't spend a lot of time on census because I'm just not going to go there. And that's 1.2. So you're starting to see that some of these sections are real simple and some of them are real short. Because I know some of y'all hadn't even opened the book because you hadn't even done the homework. I'm looking to see if I missed something here. Random sample. Is that important? Oh, yeah. Random sample. I'm trying to get to it. If I could work the computer right. There we go. A random sample. The key word that you need to write down for random sample, everyone has the same what? Chance. Write that down. Everyone or everybody or everything has the same chance. Equal chance. Let's say that I pass out each one of you, I give a yellow Post-it note and I give you a black Sharpie marker, and each one of you write your name with the black Sharpie marker, fold it in half, and put it in a bowl or a hat. Is that a random sample? Yes. What if one of you decide to use a pink? You know, I pass out the yellow Post-it notes, and you decide to use a pink one, and you fold yours in quarters and put it in the fishbowl. Is it a random sample now? No. Random sample depends on uniformity. Write that down. Random sample depends on uniformity. When I gave you each a yellow Post-it note, and I gave you each a what? A black Sharpie, I gave everybody the exact same tools to be picked. When you change the uniformity, you change the random sample. Okay? Any of you ever seen Forged in Fire? Anybody ever watched Forged in Fire before? Oh yeah, that's right, it's not a cartoon or a Marvel comic. Anyway, it's a show where the people take metal and make it into knives. Make a piece of metal into a knife. Okay, forget it. Anyway, they give you parameters, and you take this piece of metal and you make it into a knife, and you run it through a strength test, a sharpness test, and a kill test. You know, this is a terrible show. You know, weapons and killing is terrible. Anyway, but, you know, you can always play your, you know, what is it, Grand Theft Auto, where you can rape prostitutes and throw them on the side of the road? Yeah. So it's always a good alternative besides the Elmer Fudd cartoon. It's always a good thing. Anyway, I'm sorry, my sarcasm. I'm sorry about my sarcasm. Anyway, the whole point is they keep everything in the contest. They keep everything the same. And that's called pretty much a random sample, because each contestant has the same what? Chance of winning. Except, you know, the person's experience in making knives. That's the only thing different. The ambles are the same. The forges are the same. The hammers are the same. They can't use anything that's not in that, you know, picked for them. Everybody get my point? Okay. Random sample. That is a test question, and it's also a standardized test question. What is a simple random sample? A simple random sample is grouping. Now, you have some teachers and some books that, you know, they kind of differ on this, but I'm going to tell you the way I was taught at Clemson. You got to say it with a Z, because if you say it with a P, you're ignorant. So that's what ESP. You ever watch ESPN? They don't say Clemson like we do. They say Clemson. Y'all ever notice that? Okay. I just wondered if it was. I didn't know if it was just me. Okay, but I grew up as Clemson. But all of a sudden, just like I grew up in the McLeese community, grew up there. My grandfather and Henry McLeese, they knew each other, and Henry McLeese built the first school out there, and he pronounced his name McLeese. But nope, the transplant say you're pronouncing it wrong. It's McLeese. Okay, so us people and Henry McLeese, you know, he pronounced his own name wrong. So those transplants say that he pronounced his name wrong. So it's McClue's. Thank you. Who said that? You know exactly what I'm talking about. McClue's. It's McClue's. These people, they're, shut up you. Anyway, to make a long story short, this is a simple random sample, and since I was taught this way at Clemson, I'm going to teach it to you. Instead of a yellow Post-it note for each of you, I'm going to give a yellow Post-it note to this first row, and they're going to be called Group A, and they're going to take that magic marker and they're going to put Group A. They're going to put an A on it. Second group is that second line. They're going to put B, C, D. The last group is going to put E. And I put those 5 in a bowl, and I pick one of them. That's a simple random sample. So the difference between a random sample and a simple random sample is what? Group. So you need to write that definition down or that explanation down. Because when I was at Clemson and I took my several thousand statistic courses that you have to take, my teacher finally said, you know what, we're going to make this simple. And he did exactly what I just told you. And it made it a whole lot easier when you make the difference between a random sample and a simple random sample. Yes, sir.
So basically, every group has an equal chance.
Yes, every group has an equal chance. Wow, that's deep. Mr. Smith, you're impressive. Okay, you must get that from your mama. Okay, now let's move on. Let's see if there's anything. I got to look at the time because I don't want anybody to self-combust. Because I know some of y'all will start convulsing here in another few minutes. Like the funky chicken. I'm still looking. When I see something worth something, I'll. Good gracious. Oh my gosh. They're talking about building random samples. Okay, that's it. That's 1.2. Oh, 1.3, I'm sorry. Let me see. Let's see. I'm not going to go into 1.4 today because it's Friday. Now, what should everybody have done before Monday? 1.1 through 1.3 and questions sent. If you don't have 1.3, 1.2, 1.3, 1.1, 1.2, 1.3, 80% done or questions sent, you're already behind. 1.1 through 1.3 have 80% or more done or 80% in questions sent. You see what I'm saying? Okay, so anybody after Monday and they're doing 1.1, you're already behind because you're supposed to be having all that done by Monday because I went over 1.1 through 1.3 today. That's the way this class is supposed to work. Now, I'm going to call the roll and I'm going to turn off everything. And let's see. Give me a second to get everything. Okay, Giddings, Hallman, and Norton. Got to remember those because I got to do away with the screen. Come on, Tri-County, don't sign me out. So, this is so frustrating. All right. 120.24. Okay. Adams. Bailey. Baskins. Bowen. Candace. Both Bowens are here. Brianna. I didn't think Brianna was here. Branyan. Brooks. Buck. Garrett. Giddings is here. Gray is here. Which one? Tamara or Kath? Catherine's here. What about Tamara? Tamara, sorry. Tamara. Hall. Hall. Hallman. Hallman is calling in. Long. Long. Colleen. 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 Oh, she's online. Okay. Martinez. Mita. Maury. Maury. Moultrie. Maury, you here? Okay, speak up. Moultrie. Norton.
Here.
Noel. C. Smith is here. Strickland. Sullivan. Whiteside. And Turner is here. Okay. Does everybody understand my directions? Since I covered 1.1 through 1.3 today, you are responsible for having a good portion of that homework done and or questions sent to me to ask my instructor. Capiche? Because what am I starting on if I don't get any questions Monday? There you got it. See y'all. Have a good weekend. Glad y'all got to see me today. How did you know it's called glue? Did you go there?
No.
Oh, you did? Yeah, for years. Henry Mackley's, he died, his wagon got started on and broke his neck. He ran over his neck. Right there at the cotton gin. Hold on a minute before I speak. What?
You finish verification until you're not, because you don't do anything with Blackboard, so you don't want to see that.
You're here. That's all you gotta do. That's for online classes.
Alright, thank you.
What's up?
You doing all right with the things that have done? Yeah, I'm not either.
That's nothing but a Benghazi too.
Yeah.
When you have weak leaders, that's what
That's
happens.
what happens. Yeah.
And we don't have just a weak leader, we got an incompetent leader.
Did you watch this thing yesterday?
I don't watch news. I haven't watched news since November.
The dude slipped brain dead. He didn't even know who to call on like that.
Oh, hell, he don't know how to make a ham
He
sandwich.
said he was instructed.
Yeah,
He was
he said I was-
instructing the leader of the free world.
Like,
That's what I want to know. But
You
he
know
was
what?
like this.
China told him to do it. China told him to do it. He did it. And now China owns Afghanistan.
Well, my biggest thing about this is, even after that, why are we not taking back our Air Force?
Tell me about it.
Like, Cabal's done, we need to get Americans and people that helped out America, but okay.
Backstab.
Yeah, but you got Kabul here, and then you got Bagram here. So why are you sending people